The process begins as an allergen, such as pollen, is inhaled into the respiratory system and is processed by an antigen-presenting cell, or APC. The APC presents a portion of the pollen to a naive T helper cell. At this point, the APC also releases the cytokine IL-4 onto the T helper cell, which causes the naive T helper cell to differentiate into a T helper 2 or Th2 cell. A B cell also presents a portion of the pollen to a T helper 2 cell. The T helper 2 cell then releases IL-4, which activates a class switch of the B cell to cause it to become a plasma cell that produces IgE antibodies. The released IgE antibodies bind to Fc receptors located on mast cells and basophils. On subsequent exposure to the allergen binds to two separate IgE antibodies on the mast cells or basophils. This is known as cross-linking and causes degranulation that releases inflammatory mediators, including histamine. This brings about a primary hypersensitivity reaction, or early response, that includes vasodilation, bronchoconstriction, and endothelial retraction, which brings about edema. This early response begins within 5 to 30 minutes and subsides after about an hour. The T helper 2 cell also releases IL-13, which causes epithelial cells to produce mucus. A secondary reaction begins within 2 to 7 hours and may last for days. This late reaction involves the recruitment and activation of leukocytes, like eosinophils, as the T helper 2 cells release IL-3 and IL-5, and as mast cells release eosinophil chemotactic factor. Eosinophils can be destructive to tissues and cause cell damage. Lipid mediators produced from arachidonic acid are also a significant part of the late response and include prostaglandins and leukotrienes that have similar effects as histamine. Leukotrienes are particularly potent bronchoconstrictors.